Good afternoon, my dear students. In the previous class, we discussed up to some applications of work, I think, including the center of mass. Okay, if you continue here, the work part, like few examples to understand. Here, suppose if you see few questions like this, say some example here. This is say some inclined plane, Nana. And angle of inclination, you take it as some theta. Suppose a block is placed. Okay, but we are not getting that. Better I take the block. This is the block placed on the inclined surface whose mass is m. I am taking here. And if it is the rough surface, okay, from this position to the bottom, excuse me, till here, you take the displacement of body when it is left freely from there. It tries to slide down, suppose, like this. And the first question number 1 here, find the work done. Number 1, work done by the weight. Number 2, work done by the normal reaction. Number 3, work done by the friction. Actually, these are the forces acting on the body. And what is the net work done? Also fine. Okay, better I go to the next one here. Also find the net work done. Okay. So these are 4 questions here related to the given figure here. Okay. I think it is easy, Nana. Nothing to worry. You can say very easily if you are able to find out what are the directions of weight, normal reaction, and friction. You know the formula, work done by some force is equal to F dot S, that is Fs cos theta. Okay, thing is we have to find out what is the force in Fs cos theta and what is the angle between force and displacement. If you are able to find out all the problems what he asked, very easy, you can solve them. Okay, you can check here. Weight, I think, acts in this direction. Okay, whereas he gave the displacement like this. It is the displacement. See here how simple. This is the displacement and it is the weight. So very easily you can say what is the angle between these two. Okay. This is theta in the right angle triangle. You can say if it is theta, then the angle between these two is 90 minus theta. Why? Because it is a right angle 90. So in the triangle, it is theta. So other angle will be 90 minus theta in the right angle triangle. So it is very easy to understand. So simple, you observe here, both are originated from the same point. Angle between them is 90 minus theta, force and displacement. Therefore, see here how simple. The question number 1 is work done by the weight. Observe here, that is equals to Fs cos theta, original formula. That equals to F is the weight mg, displacement is S, and cos theta is 90 minus theta, angle between those two. So happily you can say here the work done by it is equals to straight away Fs sin theta. Why? Because cos 90 minus theta is sin theta. So over. Answer for the first question. Okay. Next here come to what is the second question. Look at here. Find the work done by normal reaction. Okay, take the normal reaction here. Normal reaction is always perpendicular to the surface towards the body, on the body. So towards the body, if I take the normal reaction, it is N. Look at normal reaction and displacement are perpendicular to each other. That's why in this case, straight away you can say angle between N and S is 90 degrees. Already we discussed in the previous class when the angle between the force and displacement is 90 degrees, work done equals to 0. That's why straight away you can write that implies work done by the normal reaction is equal to 0. Okay. Since cos 90 in the formula Fs cos theta, cos 90 is 0. Okay. So work done by the normal reaction equals to 0. Second part is also so simple. Third one you observe there, if you come to here, the third one. Second one is 0. Work done by the normal reaction is 0. And the third one here, what is the work done by work done by the friction. Look at here, when it's trying to slide down, I think all of you know the friction will act in opposite direction. So this is the direction of friction for you, all of you know. Means, sorry, on the block, the friction will be in opposite direction to the displacement. Exactly opposite direction means, you know, here W is equals to Fs cos theta according to the formula, where theta is equals to 180 degrees and F is the friction. Why? Because he is asking work done by the friction. Friction when it is sliding down, all of you know, mu k into N. Okay, where N on the inclined surface, all of you know, if you resolve mg into two components, you will get that is mg cos theta. So mu k into mg cos theta. No need to explain, I think. That implies the work done by the friction is F. F is mu k mg cos theta. This is F into S into cos 180. Cos 180 is minus 1. That implies work done is equals to, you are getting minus mu k mg cos theta into S. So if you keenly observe the three answers here, you can understand one point. Sir, what is that? Simple. Out of the two components mg sin theta and mg cos theta, mg sin theta is doing some work along the inclined plane. Okay, that I got here. W is equals to, where is it? Sorry, I write here not Fs cos theta, Fs sin theta. This is mg into S. Cos 90 minus theta is sin theta. Sorry. So here, this is the work done by gravity. Okay. So if you see here, who is doing the work? If you see along the inclined plane, the component of weight mg sin theta is doing the work. Okay. And next one, what he is asking, find the net work done. Net work done means in the direction of displacement. If you see there, here, this is the direction of displacement. In the direction of displacement, what are the forces acting? If you observe, this is one force, which is mg sin theta. If I resolve mg into two components, all of you know, this is mg sin theta. And here mg cos theta will get perpendicular, Nana. That's why work done by mg cos theta is 0. Normal reaction will come perpendicular. So work done by normal reaction is also 0. So here out of two components, I have to take only one component, that is mg sine theta here. Mg cos theta, already I told, perpendicular to the displacement. So work done by mg cos theta is 0. So normal reaction already 0. I explained here. And the third one here, which is not equal to 0, the friction. This is the friction. Okay. So here net work done means work done by mg sine theta in the same direction plus work done by the friction in opposite direction. This is the net work done. Net work done means you have to understand that net force into displacement. Okay. So here it is coming down. So mg sine theta is greater than F. That implies here I can write net force along the inclined plane. Along the inclined plane in the same direction of displacement. Same direction of displacement. Same direction means directly you can write W is equal to Fs, Nana. Okay, same direction of displacement is equals to F net. I got mg sine theta minus F, actually K, Fk, kinetic friction. So mg sine theta minus Fk means nothing but mg sine theta minus Fk. That is mg sine theta minus Fk is mu k into n. N on the inclined plane is mg cos theta. Okay, previously I explained. Normal reaction on the inclined plane is mg cos theta. Okay, right. So I think you can take here mg common, sine theta minus mu k cos theta, Nana. Okay, this is the net force. This is F net. That's it. It is in the same direction of displacement. So work done will be positive. That implies work done by the net force, means net work done by the net force is net work is equals to F net into in the same direction the displacement. Okay, no need to write cos theta. Same direction means cos 0 is 1. So here we can write F net is mg into sine theta minus mu k cos theta into S. That is mgs into sine theta minus mu k cos theta. This is the net work done. Okay. So on the rough inclined plane, how to calculate the net force and the work done by the net force and the works done by different kind of forces. I explained here. Okay. Suppose such a type of question, if you see here, one time what he gave in exam, like suppose if you see one example here, that example is he placed a block of mass m on a platform like this. Suppose this is a platform and it is the block placed over it. Okay, it is the platform and it is the block. I am taking mass of the block as m. Okay, now. And then here what he did, sir, after placing that, the platform starts from rest. Okay, the platform starts from rest and it goes up like lift, Nana, starts from rest and goes with constant acceleration upwards and moves with a constant acceleration. A constant acceleration. How much, sir? Yeah, that I'm showing here. Constant acceleration going upwards with an acceleration like lift. Lift is going up with an acceleration a is equals to g by 2. Okay, with an acceleration a is equals to z by 2. Then the question is here, what is the work done? Find the work done by particularly normal reaction, Nana. By normal reaction, normal reaction in a time t or as a function of time in a time t is, he is asking. Okay, so here if you see the question properly and understand the question properly, you can send very easily in what direction the normal reaction acts. It always acts in the upward direction. This is the normal reaction. And of course, weight of the block that always acts, it acts downwards. It is a common thing from the center. Okay, so it is mg. Okay, here if the platform is at rest, then what is the normal reaction? If I ask, straight away you say, sorry, here it is placed on a surface, so n is equals to mg, sir. But problem is the platform is not at rest. It is going up with an acceleration a is equals to g by 2. It is going up means it is getting some net force upwards. So if you see here and understand the question properly, one force is n, other force is mg, but I'm getting net acceleration a is equals to g by 2. Means net force I'm getting here F net is equals to, I am getting m into acceleration, that is g by 2. Okay, given Nana, a is equal to g by 2, he gave. So m into a, that is g by 2. I am getting some net force in the upward direction means, surely you can understand that the upward force is greater than the downward force acting on the body. Means surely, definitely you can say, sir, you are getting the net force upwards, sir. That's why n, no doubt, without second thought, you can write n is greater than mg, sir. Okay, n is greater than mg means I can write F net is equals to, since they are in opposite direction, I have to write n minus mg is the net force. Okay, I think you understand this point. So F net, he gave m into a, that is g by 2. So mg by 2 is equals to n minus mg. So observe here, I am not getting n equals to mg when it is accelerating. That you have to understand. So when is this n equal to mg? When the platform is at rest, means acceleration equals to 0. When acceleration is 0, F net equals to 0. F net equals to 0 means n minus mg equals to 0. So n equals to mg. So when the platform is at rest, n equals to mg. But when platform is in motion, we have to do like this. Okay, that implies, observe here, n is equals to, if I take mg to the other hand, mg plus mg by 2. That I am getting 3mg by 2 nano. Okay, so I got normal reaction is equals to 3mg by 2. And keep in mind, normal reaction, I got the formula mg plus ma. Keep in mind. Okay, so he is asking find the work done by normal reaction in a time t. Normal reaction upwards. It is the the platform is going up. So surely the displacement will be in the upward direction. No doubt. Why? Because the platform is going up. That's why I write here, draw here. It is the direction of displacement. Okay. It is the direction of displacement means force and displacement both are in the same, normal reaction and displacement are in the same direction. Okay. So work done by normal reaction means same. Directly I can write Ns cos 0, 1, force into displacement, N into S, I can write in the next page. So if I come to here, that implies work done is equals to Ns cos theta formula, force into displacement into cos theta, work done by normal reaction. Ns cos 0, they are in the same direction. So Ns. Okay. Of course, N I can substitute. I found here this is 3 mg by 2. So I write here 3 mg by 2 into displacement. Sir, displacement is not given, sir. No problem. Already you know the acceleration moving upwards. Na? That too, g by 2 means constant acceleration, and he said started from rest. Clearly in the question. So started from rest, accelerating upwards in a time t. How can you calculate the displacement? Using the formula, since acceleration is constant, ut plus half it square, you can use nano. After a time t, what is the displacement? So S is equals to ut 0 half acceleration, he gave it as g by 2, moving up with this acceleration, into t square. That implies S is equals to, I'm getting g by 4 into t square. Okay. Therefore, I'm getting work done is equals to, from this formula, 3 mg by 2 into displacement is g by 4 into t square. 3 mg by 2 into S. S is g by 4 into t square. So look at here. Therefore, final answer you are getting W is equals to 3 mg into g square t square by 3 4 2s are 8. So you are getting the answer 3 by 8 m into g square t square. This is the answer, Nana. I think all of you understood how to calculate this work done. Okay. From here. Of course, this was the question given in 2019, Nana. Okay. This was given in 10th January 2019. Okay. In exam. So I think you don't have any doubt related to this question. And luckily in this question, you understood one concept. Okay, when some platform like lift is accelerating upwards, the normal reaction is appear like mg plus m, g by 2 is a. So m into a. So you can write here, when that point I write in the note, a platform or lift is going up with an acceleration a, which is given in the previous problem g by 2 a, then the normal reaction on the body or a person in the lift, on the body or the person in the lift, is equals to, I write here mg, no need to derive, none, already I derived in the previous question, mg plus m a, g by 2 is nothing but a, mg plus ma. Or that you can write it as by taking common also m into g plus a. That is your wish. Okay, this is the point 1 here. And in the same question, if I ask if the lift or platform, anyone, is going up with uniform velocity, Nana? When a body is moving with uniform velocity, anyone remember? Acceleration of the body equals to 0 when it is moving with uniform velocity. Keep in mind, going up with uniform velocity, then n is equals to, I write here, mg plus m into acceleration is 0, Nana. N is equals to mg. You have to understand. So while looking these kind of problems, first you check, not this word, going up, that is not important. Going up, correct, with an acceleration or with uniform velocity, once you check, Nana. Okay, just by seeing the cover, if you judge the problem, you may get the wrong answer. Going up, directly if you take n is equal to mg plus e and blah, 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 if you try to solve the problem, you will get the wrong answer. Going up, correct, but with an acceleration or with the uniform velocity, that you check. With an acceleration, it is the formula going up. With uniform velocity, this is the formula. Okay, right, I think you followed here. With an acceleration, with uniform velocity. Okay, both while going up. And the third point here, when it is at rest, in the problem I already explained, when the block is at rest, n equals to mg. Why? Because a equals to 0 at rest. So if the lift or platform is at rest, like at the ground floor, at rest, here in this case also a is equals to 0, then n equals to mg. Straight away we write. Okay. And here the fourth point is, okay, that platform is not going up, not going from ground floor to fifth floor. It is coming from fifth floor to ground floor. Fifth to ground means you are going down. Okay, that's why here if I say, if a platform or lift, okay, or lift is going down, not up. Okay, again you have to check with an acceleration or with uniform velocity. Suppose I say with an acceleration a, okay, Nana, then what will be the normal reaction? Then the normal reaction will be, okay, is, look at, Nana. Now if it goes down like this, out of the two forces acting on the body, n and mg, the lift is going down means you are getting net force is equals to ma downwards, Nana. Why? Because this is going down. Net force ma means you have to take mg minus n or n minus mg. Obviously mg minus n. Why? Because downward force should be greater. Why? Because you are getting net force downwards. That's why from this figure, here directly I am erasing and going back to that page. Here again I draw the normal reaction and the weight and the net force. Okay, this is the net force. So if you see here, it is the normal reaction. It is mg. I got net force downwards. Why? Because it is going down with an acceleration a, which is equals to ma. So surely mg is greater than n. Is dash. If you ask, then I am coming to here. That implies downward force is greater. So mg minus n is equals to, I have to write F net, which is equals to ma. So just interchange the two terms. N is equals to, I have to write mg minus ma. So you can write that implies n is equals to either mg minus ma or m into g minus a when it is going down. Okay, try to remember when the lift is going down. Okay, this is lift going down, platform going down with an acceleration. So same type of question if I ask with uniform velocity, you can say a is equals to 0. So n is equals to, straight away you can say mg. That's why next point, if I write here, fifth one, here if I write, if the lift is going down, it is not important, going down, okay, with, yeah, this is important, uniform velocity, okay, uniform velocity, acceleration 0, okay, then n is equals to, again I'm getting mg. Okay, this is one more point here. Suppose here if they ask, like the sixth point here, the lift is falling freely. A lift is or platform is falling freely. Okay, all right. Here you can see in amusing parks, Nana, there they try to keep you on a sofa set, and then they try to bring you downwards, and suddenly they leave. Means you fall free. At that time, what will be the normal reaction? What we feel? Okay, if you see here, lift is falling freely means it falls downwards, Nana. While falling freely, all of you know, in the motion in a straight line chapter, when a body is left freely to fall freely, its acceleration will be equals to g. All of you know that. Okay, and falling freely means coming downwards. Coming downwards means normal reaction will be, is for a is equals to z. That implies normal reaction will be mg minus m into a is g. That implies you are getting normal reaction equals to 0. When the normal reaction equals to 0, suppose in the amusing park, okay, like Wonderla, Nana, there, suppose you sit on a sofa set, and here, suppose you sit like this, okay, and normal reaction becomes 0. The problem is when the normal reaction equal to 0 on a surface, when you leave the surface, means you will come out of contact of the floor, means that sofa set, out of contact, then you will float in air. That's why what they do, they try to fix you with some hook here, right? And then they try to keep you on the sofa set. Okay, that belt will try to keep you in contact with the sofa set all the times, even though the normal reaction equals to 0. That's why you won't come out of contact of the sofa set. No problem, no need to worry there. No need to shout, okay, no need to cry, and no need to pray the god. Okay, directly you can safely land there downwards. So again, why? Because while coming down, they try to decelerate that sofa set while coming down. Okay, that is really a great feel. If you go to the Wonderla, once you feel that, you may enjoy. This is the normal reaction on you. Okay, right. When it is falling free, keep in mind, right? And seventh one, here what I say, a lift is decelerating, not accelerating, decelerating downwards. Decelerating downwards means acceleration should be negative. That implies a is negative. Okay, downwards means I have to take this formula. That implies normal reaction equals to, I have to write mg downwards minus m a decelerating. That's why minus a I write. So I will get n is equals to mg plus ma. This is when it is decelerating downwards. Okay, then immediately you may ask, sir, decelerating downwards, okay, sir, decelerating upwards, Yeah, sure. A lift is suppose is decelerating upwards, then you can say upwards acceleration is for negative none again, but moving upwards once we check there, while accelerating upwards formula is mg plus ma. So here I have to write n is equals to mg plus m. A is negative minus a. So I have to write n is equals to mg minus ma. Right? I think you understood this point also here. Okay. So these are different cases, Nana. So anyone in your exam in 2022, they may ask like this. Suppose they may ask, block is placed similar. This is was given in 2019. So in 2022, for your batch, when you come to senior, complete your senior intern, write the mains exam. At that time, they may ask on a platform like in the same type of question, a block is placed M and it is started with some initial velocity and it is decelerating upwards with A is equal, suppose given minus G by 2. At that time, what is the work done by normal reaction means? First of all, you have to come to know normal reaction equals to how much? Na? That I told here. Going up, decelerating, n is equals to mg minus ma. By this, you have to calculate the normal reaction. Already you put minus a, Nana. You don't apply the negative sign 2 times. Again, don't substitute a is equals to minus g by 2. Then that becomes plus g by 2. No use. Already the negative sign I applied here. So simply you substitute a is equals to g by 2 here. That minus already I substituted here. Keep in mind. That's why don't substitute negative sign 2 times. Okay, good. This is your deceleration here. Okay, that's why I explained all the models here, Nana. And here what he says, this is a equals to g by 2. All right. What he says, suppose in the lift, you place one weighing machine. On the weighing machine, one person stood and then proceed, suppose fifth floor from ground floor. It is accelerating up now. Then the weighing machine reads how much readings are. The weighing machine reads your weight mg or mg plus ma if you ask. Then I say whatever the force applied by the weighing machine, that reading the weighing machine reads, Nana. The force applied by the weighing machine is normal reaction. So normal reaction is the reading that it shows on the scale. Okay. So normal reaction means if you want to get your weight, you have to place that weighing machine in the lift when the lift is at rest. When the lift is at rest, N is equals to mg so that you can measure your weight, own weight. Suppose when you press the fifth button and it is started accelerating, then here the normal reaction is not equal to your own weight, mg plus ma you are getting. That's why it is the problem. What the reading you observe when you place the weighing machine in the lift and tries to read your weight. Okay. So the weight read by the weighing machine is not your weight. That is the normal reaction applied by the weighing machine. So that normal reaction, whatever it measures your weight, is called as apparent weight, Nana. So when you come to numericals, what they ask, when the lift is going up, find the apparent weight. Apparent weight is nothing but normal reaction. Okay, so keep in mind that point here I write there. I think all of you understood. Apparent weight is nothing but the weight measured by the weighing machine. So here, in all these cases, last but not least, don't neglect this point, the normal reaction measured by the weighing machine weighing machine is nothing but the apparent weight of the body. That's why I conclude that normal reaction is nothing but when you come to the weighing machine, that is apparent weight. That's why even they ask this model, when a lift is decelerating upwards with some negative acceleration, what is the apparent weight means? I have to write n is equals to mg minus ma. This is the apparent weight. Okay, is it clear, Nana? Right. These are few points related to here the class today. Okay. Still few other models are there. Those models we will discuss in the next class. Okay, Nana? Bye everyone. Right. If possible, you try to watch it today.